Now we introduce an objective function for policy gradient algorithm. In the reinforcement learning scenarios, agent act in a stochastic environment. Markov decision process is applied to search for optimal policy for agent. So the agent can select actions under the policy to receive the maximum expected reward. That's the problem we need to solve. Of course, to solve this problem, we need to create an objective function. Then we use the gradient method to solve it to get the optimal policy. Say agent at state S and follow the under the action pi select action in the stochastic environment to get a reward, and step by step reach to the terminal state, and we back up. From backward. In backward direction, we calculate the cumulative reward, and then we use the same policy, work on all the possible passes. Finally, we got the expected reward. The policy we are searching for has the maximum expected reward. So that means, we under the pi policy, we go through all the possible passes, get the cumulative reward for each pass, and then for all the passes under the same policy, we get the expected reward. And the policy which has the maximum expected reward is what we are looking for. How to create the objective function? The objective function should be we use the gradient ascent method. That means we need find a policy, make this function is maximum. That's the idea. The maximum first, this function is the expectation reward. Let's say this objective function includes two parts. One part is called possible state distribution. Distribution means this the future discounted factor. That means in the future we are not sure exactly what the reward we will receive by selecting the action under the policy. And this one is at the initial state, what's the probability, and here is the state transition probability. That means this distribution, state distribution, tells us how from the initial state to the terminal state. And the second part is the policy, related to the policy and the reward. That means at this state, we use this under this policy, take this action, and follow one of the state transaction probability, we receive the reward R. So this here theta is the model parameters. So if we want to find the maximum value of the objective function, so we need to calculate the derivative of the objective function with regard to the model parameters theta. The theta, right now here is the objective function. We calculate the derivative of the related to the with respect to the theta. So because this part is no relation with the theta, and here this also relation with theta. With theta only, because it's only with related to the policy. So here is we just calculate the gradient of the policy. It's very simple. So this is very popular method for continual action space to search the optimal policy. For more detail, can check with these references. Thank you.